Hello everyone, good morning to one and all. My name is Kiran Kumar. Today my Techtalk topic in facts is types of fact controllers. In general, fact controllers can be classified into four categories. Uh, Series controllers, shunt controllers, combined series shunt controllers, and combined series controllers. These are the general systems of fact controllers. Figure A shows a general symbol of fact controller. Figure B shows a series controller. Figure C shows a shunt controller. Figure 4 shows unified series controller. And the below figure shows the schematic diagram of fact controller. It shows the general symbol of facts controllers with a stylized arrow inside a box. Figure second 2.2. This figure shows the series controller could be variable impedance such as capacitor, reactor, etc., or it is a power electronics based variable source of main frequency, substation, synchronous frequency, and harmonious frequencies. Observe the figure for a minute. Coming back to the topic, series controllers is used to inject the voltage in series with the line. Even variable impedance multiplied by the current flow through it represents an injected series voltage in the line. So as long as the voltage is in phase quadrature with the line current, the series controller supplies or consume variables reactive power. If any other phase relation involves, it will handle the real power also. The above figure shows the shunt controllers as series controller. Should the shunt controller also as variable impedance, variable source, or a combination of all. The principle of shunt controllers is to inject current into system of the point of the connection. Even variable shunt impedance connected to the line voltage causes a variable current flow and hence represents injection of the current into the time. As long as the injected current is in phase quadrature with the line voltage, the shunt controller supplies or consumes relationship involves, it also handles the real power. The figure shows the combination of two separate series controllers which are controlled in a coordinated manner in a multi-line transmission system. Otherwise, it could be a unified controller. And the series controller provide independent series reactive compensation for each line and also transfer the real power among the lines via the unified series controller referred to as interline power flow controller, which makes it possible to balance both the real and reactive power flow in the lines and thereby maximizing the utilization of transmission system. Note that the term unified here means that the DC terminals of all converters are connected together for real power transfer. It shows the combined series shunt controller. This could be combination of separate shunt and series controller which are controlled in a coordinated manner. Reunified power flow controller with the series and shunt elements. The principle of combined shunt and series controllers is used to inject currents into the system with the shunt part of the controller and voltage through series part. However, when the shunt and series controllers are unified, there can be a real power exchange between the series and the shunt controllers via the power link. And the benefits from fact controllers. Control of power flow is in order meet the utilities of own needs, ensure optimum power flow, and ride through emergency conditions or a combination of all. Increase the loading capability of lines to their thermal capabilities, including short-term and seasonal. This can be done by overcoming other limitations and sharing of power among lines according to their capability. Increase the system security through raising the transient stability limit, limiting short circuit currents and overloads, managing cascading blackouts and damping electromechanical oscillations of power system and machines. Provide secure tie line connections to neighboring cities and regions, thereby decreasing overall generation reserve requirement both sides. Provide generator greater flexibility in settings now new generation. Provide upgrade of lines, reduce the reactive power flow, thus allowing the lines to carry more active power and reducing loop flows also. And the another topic is VSI, that means the voltage source converter. Here is the single phase full wave bridge converter. So it shows the single phase bridge converter consists of four values The capacitor to provide stiff DC voltage and two AC connection points with A and B. The designated valve numbers represent the sequence of a turn on and turn off operation. The DC voltage is converted to AC voltage with the appropriate value turn off sequence as explained below. The figure above, the below figure shows the single phase full wave bridge converters. It contains AC voltage and AC current. The AC current rectifier inductor and value voltage. From instant T1 to T2, when device 1 and 2 are on and 3 and 4 are off, VAB is positive and IAB is negative. The current flows through device 1 into AC phase, out of AC phase B through device 2 with the power flow of DC to AC. From instant T2, the current reverses, it becomes a positive and flows through diodes and 1 and 2 with the power flow AC to DC. From instant T3 and T4, device 1 and 2 are off and 3 and 4 are on. VAB becomes negative and IAB is still positive. The below operation mode of single phase full wave bridge converter shows the table. In first order, the devices namely 1 and 2 are on, 3 and 4 are off. VAB is positive if 1 and 2 on and 3 and 4 are off, and IAB is negative while 1 and 2 is on and 3 and 4 is off. Connecting devices are 1 and 2. The conversion is inverter, and if 1 and 2 are on, 3 and 4 are off, VAB is positive and IAB is negative. The connecting devices is 1 and 2, and the conversion is rectifier. If 1 and 2 are off and 3 and 4 are on, VAB is negative and IAB, we know that it is a positive, and connecting devices are 3 and 4. Conversion is inverter. If 1 and 2 and off and 3 and 4 are on, VAB is negative and IAB is also negative. Conducting devices are 3' and 4' rectifiers. The below figure shows the 3-phase full wave bridge converters. Need to observe for a minute. You can observe. Here is a phase to DC midpoint, and VD is also there. We know that VAB is equal to VA minus VB, and VB is equal to VB minus VC, and VCA equal to VC minus VA. The following waveform shows the current from VA, DC current from PH to B, DC current from PH to C, and total DC currents. These are the 3-phase full wave bridge converters. The above diagram shows. With the 6 valves, there are designated in the order. 1 to 6 represents the sequence of valve operation in the time. It consists of 3 legs 120 degrees apart. We all know it. And transformation connection for 12 pulse operation. The below diagram shows it, the waveforms and transformation connections. And the circulating current of each non-12 pulse harmonics is given by, we know that IA by IA equal to 100 by X or into N square percentage. I think almost the topics in the Techtalk I covered. Thank you for giving this opportunity.